This is how the lecture part 2 will look like. So you will see a video of me trying to fill out the lecture notes, and you will have to answer the questions that appear on the screen. And if you answer correctly, you get 0.5 points, and if you answer it wrong, you still get 0.1 points. So let us first start by asking an easy question. So now you will see on the left side of your screen, in a moment you will see a question. So you will answer the question correctly and then press continue to continue the video. Alright, so that's how it works. So let's start with the lecture 0 part 2. So on lecture 0 part 2, I'm actually doing some math. And so we will talk about fractions because you will have to do a lot of fractions in this course. So it's better to know how to deal with them correctly. So let's talk about some basic rules when you have to do fractions. Now the first one is equivalent fractions. So equivalent fractions is, for example, like 2/3 and 4/6. These two are equivalent fractions. Just think about it like this. Let's say someone gives you a 2/3 of a pizza, cuts it to three, and gives you two parts. Or someone else cuts the pizza into 6 and gives you 4 parts, and you can see that they are the same. So 2/3 and 4/6 are the same number that are written in different forms, so we call them equivalent fractions. They are essentially the same. Okay, and sometimes, and this is also equal to, let's say, 6/9, and so on. So if you have a fraction and then multiply the top and the bottom by the same amount, let's say 5 and 5, you will still get the same fraction written in a different form, and in this case it's 10/15, and so on. So that's the first thing, the equivalent fractions. So you might use equivalent fractions when you do addition and subtraction of fractions. Now, rule of signs. Now this is something some people get confused on, is where does the negative sign go and what does it mean? And in fractions, if you have a single term on the top and the bottom, it doesn't really matter where you put the negative sign. So for example, negative 5/6 is the same as 5/6 is the same as negative of 5/6 as a fraction. Okay, so if you see me having this one and then just going to that step, it's because it's a rule of signs. Okay, but if you have negative 5/6, you can just ignore the negative sign because it's negative divided by negative, so it's plus 5/6. And as I said before, if you get a fraction and multiply the top and the bottom with the same amount, except for 0, of course, you will get an equivalent fraction. And that is very important when doing addition and subtraction, and as you will see in the next example. Okay, and then if you have the same denominator, you can just add the numerator, and that's how you add fractions. For example, 2/3 plus 5/3, because the denominator is the same, you can just add the numerator, so it's 2 plus 5/3, so that would be 7/3. But if the denominators are not the same, then you will have to think about the least common denominator. But let's say in a simpler case, they don't have common denominator. For example, 7 and 5. They are not common. Nothing is common in 7 and 5. They are mutually prime. That's what we call it. Let's say you have to add 2/7 and 3/5. Okay, and in this case, what we would do is, we will look at this denominator. I want to make this the same denominator, so I would multiply this by 5 and 5 here, and here I would multiply by 7 and 7. And remember, when you do the same number in the top and the bottom, you get an equivalent fraction, so you get the same number. Okay, now you have 35 here, and on the top you have 10, and you have 35 here as well, and on the top you have 21. Okay, now because they are the same, you can just add it at the numerator. So 10 plus 21 over 35, and that would be 31 over 35. Okay, and then that's how you add or subtract with unlike denominators, especially when there are no common factors. Even if there are common factors, you can use this method, but when that happens, it would be, you would get a different but equivalent answer. And multiplying fractions is easy. Simply multiply the numerators together and write, multiply the denominators together and write. So for example, 7 over 9 times 3 over 5, and that would be 7 times 3 is 21, and 9 times 5 is 45. When you divide, though, you need to flip this. By flip, I mean take the numerator to the denominator and the denominator to the numerator. So it would flip, and then you multiply. So a over b divided by c over d becomes a over b times d over c. Okay, so for example, the same thing, same numbers as before, like let's say 7 over 9 divided by 3 over 5. Now you need to flip this guy. So you would end up with 7 over 9 multiplied by 5 over 3. And then you just do the simple multiplication. On the top you get 35, and in the bottom you get 27. And that's it. So these are the basic operations of fractions. Let's do some examples. So in the next page you will see some examples right here. And you see the fractions have unlike denominators. And also, because there is 72 here, you might wonder, okay, what would be the least common denominator here? And as you can see, 9 times 8 is 72, and they don't have any common factors. So the least common denominator in this case is 72. So in order to make this 72, I will have to multiply it by 8, and I will have to multiply the denominator by 8 to make it an equivalent fraction. And here, in order to make the denominator 72, I would multiply it by 9, and then I will have to multiply the numerator by 9 to make an equivalent fraction. Okay, so what we have here is 8 over 8 times 9, which is 72, minus 9 over 8 times 9, which is 72. Now, and also you should understand that you need to do the things inside the parenthesis first, and then you divide it by 1 over 72. You're dividing by 1 over 72. Okay, so let's do the parenthesis first, and you have 8 minus 9 divided by 72, all divided by 1 over 72. And as you can see, 8 minus 9 is negative 1 divided by 72, division 1 over 72. Now at this point you can actually do the fraction division, which means you flip and multiply. So negative 1 over 72 times 72 over 1. And as you can see, this is the place where we do something called crossing things off. So if there's only one term or a single term in the numerator and the denominator, you can just cross it off like that. You have to be careful when you have multiple terms but in this case there are no multiple terms, there's just a single term, so you end up with -1 divided by 1, which is -1. Okay, so let's do the other one. Here again you have to do the division because it's inside the parenthesis, and when you do division, remember you would flip it. And for the moment, let's do this placeholder thing just to make sure everything is correct and clear for you. Okay, now we have a placeholder just because if you want to flip, you know how to correctly flip it. Okay, now here this division would become a multiplication times 3/2, and here this division will again become a multiplication, and I'm going to do that simultaneously, times this goes to the bottom and once 1 comes to the top. So now it's just a multiplication, so 2 times 3 is 6, 1 times 2 is 2, minus 2 times 1 is 2, or 3 times 2 is 6. Now I could have done this, which is easier. I just realized that you can just cross this off, and you can just cross this off, and you should end up with 3 minus 1/3. Okay, now again you have a fraction subtraction, but you don't have the same denominator, so I need to make this 3, and I would make this 3 on the numerator as well, which means I have 9/3 minus 1/3, which is just 9 minus 1/3, which is 8/3. Alright, so let's go to the next example. And the first thing you can see is there's just 2 negative signs. You can just ignore them and write 9/25. And this large fractions means division, so this thing means division. So just to make things simpler, so that we don't have fractions of fractions, you just make it divided by 36/15. And because it's a division, you can just flip the second one and multiply. And this is how I would do it. Rather than doing 9 times 15 and 25 times 36, I would seek out common factors and cancel them. And this is the way you should do your multiplications as well. I mean, it's not wrong, but it will take a lot more time if you actually do the multiplication. So right here, 9 is 9 times 1 and 36 is 9 times 4. That's how we do it. 15 is 5 times 3, 25 is 5 times 5. So now you have much simpler things to multiply. You have 1 times 3, that's 3, 5 times 4, that's 20. And that's it. So the final answer in this case is 3/20. Now, at this time we can just you can just stop and answer the question you can see on the right hand side of the screen. Alright, so I hope you got that. And then I have 3 different errors that I see all the time, so I just thought that it would be better to address them at the very beginning. So there are multiple errors, but these 3 errors are very common, so I don't want you to do these errors when you do your algebra. So the first one, common error 1 in algebra, is not doing the distribution step correctly, or rushing to the cancellation step. Now let's see this example and let's see how it's done correctly, and let's see how things can go wrong. Okay, so the question is, multiply both the numerator and the denominator of the following expression by x plus 1 and simplify. Now for the moment I just want you to try that without looking at the video if you can, but and then look at what I'm doing. Okay, so I'm going to multiply the numerator. That would be x times x plus 1, and the denominator again multiplied by x times x plus 1. Now the crucial step that I always find that students do not do is the distribution. Now you can see there are multiple terms where you have to distribute this to all the terms. So the next step, you need to write it down that you have distributed without trying to cancel things off like that. Okay, so let me write down what was there first. 1 over x was there, and then you had minus 1 over x plus 1 divided by 3 over x plus 1 minus 2x over x plus 1. That's what you had originally in the question, and you were multiplying, and the distribution step, you will be distributing it to all the terms. Now that would be x times x plus 1 here, x times x plus 1 here, x times x plus 1 here, and x times x plus 1 here. Okay, now you can cancel it. So this is the step where you can cancel stuff, not the previous step. Do not cancel things like that. Okay, I'm gonna show you how that can go wrong. Okay, now this cancels off, this cancels off, cancels off, and cancels off. So now you get a nice fraction. This is something we call in mathematics a complex fraction, and once you do the correct multiplication, you don't get a complex fraction, you get a nice fraction here. X plus 1 minus x divided by 3 minus 2x squared. So x minus x is 0, so you get 1 over 3 minus 2x squared, and that is the answer. Okay, now what can go wrong here is trying to cancel things like that. For example, let me just show you the numerator. Okay, and I know in this question this might not be a huge deal because you know something is going wrong when you get 0, but there are some questions, if you get this, if you cancel this, if you just can't resist the temptation to cancel this, and then you get a very tempting answer that you would think this is the correct one, but it might not be the correct one. So let's see. People would like to cancel it like this and this. That's not the way to go. Okay, so make sure you do the distribution step. Okay, so the common error here is trying to cross off factors without doing a proper distribution. So doing the proper distribution is key here. Okay, so properly write down the distribution step, and you might find this very useful in the future when you do a lot of questions, especially complex fractions and difference quotients. Okay, the second common error in algebra is so common. There's a name for it. It's called the freshman's dream, because a lot of freshmen tend to do that mistake. Okay, so no offense if you're a freshman, but well, I've seen it regardless of you're a freshman or not. I've seen students doing this very common mistake. The mistake is thinking, well, these things are individual terms squared, so you may end up writing 4x squared plus 9, which it is not. Now, right now, if I just give you this question, you would say, okay, it's not. You will actually find the answer. But more often than not, these types of steps come in the middle of the question. So you will be doing something else, and all of a sudden you will have to expand this, and you will end up expanding it like this the wrong way. So always remember, whenever you have a squared term and you actually have to find the value, make sure you FOIL it. Okay, so let's FOIL it. And when you FOIL, nothing can go wrong. Okay, so first terms 4x squared, inner terms 6x, out middle terms, or outer terms 6x plus last terms 9. So you end up with 4x squared plus 12x plus 9. Now there is a formula for this that we will discuss in the future, but foiling always works. So whenever you see a perfect square term, and if you keep doing this error, make sure you stop there and foil it. And this one right here is another form of a freshman stream that you would just do x plus y, which is wrong. There is no simplification for this. You will have to, that would be the final answer. You cannot simplify something inside a square root when there are multiple terms unless there are common factors. Okay, the third one, again, people would feel like writing down x cubed plus 2 cubed, which is wrong. In order to do it correctly, you will have to FOIL it. Now in this case, it would be 3 times. And when you do that, you will just simply first do one FOIL and then do it one more time. So here you should end up with x squared plus 2x plus 2x plus 4 times x plus 2. Do one more simplification step, x squared plus 4x plus 4 times x plus 2. Now we are not FOILing, we are doing this multiplication 3 times or 6 times. So you might have to be very patient to get the correct answer, but it should end up being x squared, x cubed plus 6x squared plus 12x plus 8. And there is also a formula for the perfect cubed that you will learn in lecture 3. Okay. So remember, do not do the freshman's dream error. Okay, so the third and the last mistake that I've seen is called cancelling without common factors. Okay, so again, the reason is it's very tempting for you to do. Let's say you have x plus y over x. It's very tempting to cancel things off like this, and then just write 1 plus y, which is wrong. So the reason that this arises is when you have multiple terms on the numerator or the denominator. So if you get multiple terms on the numerator and denominator, to avoid this mistake, always take out the common factors before cancelling. Okay, so right here you will see there are no common factors, so there are no simplification. Okay, and here in this step you will see that there are common factors. You can actually take x as a common factor on the top, 1 plus y, and x as a common factor on the bottom, and then you will just cancel off, and you can see that it's simply 1 plus y. Now you might be surprised that how many times I see these mistakes in students' answer sheets. So just be very careful when you do these type of questions. Make sure you take the common factor out and then cancel. Now right here again you can see 3 and 3. Do not cancel it because there are more terms and there are no common factors, so there is no simplification. Okay, so remember, the story from here is always look for common factors. Okay, now that's the end of lecture 0, and you can answer the question you see on the right side of the screen, and once you do that, the lecture will end.